everyone. We are team host from Manit Bhopal. The problem statement of our deals with detecting drug sales on encrypted platforms. The topic itself emerges a concern because the major youth of the country is nowadays involved in this thing. If I tell you about the data reports of UN, it estimates that near about 2.4 to 3 million people across this world right now are dealing with drugs every year on specifically the app's names as Telegram, where our solution emerges that how we're using the Telegram API via the Telethon Python client to scrap the live messages from targeted public communities, wherein we would be using certain tools which would be very much beneficial for detecting the multilingual content, which can be either content, emojis, and we'll also be using the multimodal inputs wherein different types of text, images of drugs can be detected. The major utility of our problem statements comes in the difference where we are using the transformer based model, which is unique and different from the usually used models.
Here comes the third point, core model used. So we are using Roberta BERT fine-tune for drug detection. This model is based transformer based for text classification and emoji classification. Then comes the second model, that is multilingual support. So we are using this model to because uh, in our application we are detecting several different types of drugs and different regions of drugs uh, in different countries. So we are using XLM Robert MBERT for detecting different languages. Then comes the image analysis. So for image analysis, we are using clip and vision transformer to detect drugs, pills, powders, packaging, and logos of the different drug companies. Then comes the fusion layer. So we are fusing all of these inputs into one single output, and here you can see that this is the output of our solution, data collected in JSON format. So let's discuss the pipeline workflow of our project. We are targeting Telegram. So we are using Telegram API, that is Telethon, to scrape the messages from the groups. Then the data is collected in this format. You can see the format of the collection of data. Text is can I have some oxy set. So has media true, then this type of JSON format is created. Then comes the second step, that is pre-processing. Before analysis, the raw data is cleaned and normalized, and so that for detection of drug, it becomes easier to classify what type of drug and how much harmful it is, and uh, what is the risk score, confidence score of that drug is, or of that group. Then comes the text analysis. So transformer based, we are using transformer based language model, that is Roberta, that is used to classify the text, whether the given text is drug related content or not. And we are using XLM Roberta to for the different types or different kind of languages. Then comes the image analysis, third step, that is fourth step, that is image analysis to detect visual evidence. If in the group is there, if there is any visual evidences of the drug, like uh, I have explained before, that is drugs, pills, powders, packaging, and logos from the attached images. If in the image it is there, then it can be detected using clip model. Then comes the text extraction from image using Gemini Vision. As if any text is written in image, that can be extracted using Gemini Vision. Here is the detected content. So here is a sample of it. So here uh, you can see that uh, I want, if you want Xenex, it is written in image format. So our model detected it and scored it that it is its risk level is medium, and it is a term related to slang, type of slang. It is a type of slang used to like used to refer a drug. Then comes the emoji detection. Here's the emoji detection and its output. Then comes the explainability layer. So for law enforcement usability, an explainability module highlights the exact cues that trigger detection. For instance, it may underline suspicious keywords, map slangs to their meanings, or visually mark drug like pattern and images, enabling transparent and actionable insights. Then comes the interactive dashboard. All the processed results are displayed on the Streamlit-based dashboard, providing the law enforcement with an intuitive interface. The dashboard shows flagged text, annotated images, detection confidence levels, and trend analytics, enabling quick decision making and real-time monitoring. So our dashboard is very user-friendly also.
Now, if I talk about what's the uniqueness and innovation of our solution, then the very first thing which comes, as I mentioned, that we have a dynamic slang dictionary, wherein every single time a new word which is being used by any person over the channels is getting encrypted and stored uh, in the database. If we talk about the second, wherein we have a multi-prompt detection, where any kind of emoji or slang which shows that there is slight possibility of drug being sold, it detects and immediately informs the user. Then we have the multimodal analysis, wherein we are using the NLP Robata and Clip VIT for images purposes. We have multilingual and local adaptability, which would be supporting all the languages, and also it would have the law enforcement friendly interface, wherein the dashboard designed for non-technical users also, they would also find no difficulty in handling it. If we talk about the explainability, then we can highlight specifically on the slang, emoji and visuals, wherein it would trigger that something is getting detected over the platforms. Now, lastly, if we talk about how our solutions directly aligns with Thales' core vision of building a safer, more secure and digital world through cybersecurity and digital identity innovation goes in that as it's in our core, the solution itself embodies Thales cybersecurity, where we are protecting the digital world through advanced AI-driven threat detection. Lastly, we have developed a real monitoring system which would directly align with Thales' vision.
Its technical approach is built around modular, scalable, and adaptive intelligence layers, ensuring the system can evolve alongside criminal communication patterns. It employs distributed crawlers built with Telethon and Scrapit to continuously monitor multiple platforms. It collects messages, attachments, and metadata in real time while maintaining respect for legal access boundaries. The collected data is standardized. Language detection in English, Hindi, or English ensures proper routing, while slang normalization and emoji interpretation make text understandable for models. OCR extracts hidden text from images and Whisper transcribes voice notes into searchable text. Its HERT combines multiple transformer models like XLMR for multilingual text intent detection, OpenClip or VIT for image understanding, and Whisper for speech. A fusion transformer merges these modalities, specifically embeddings into a single risk score, enabling the model to interpret mixed media posts seamlessly. A continuously updating slang and emoji dictionary powered by co-occurrence analysis and semantic similarity ensures the system remains current with evolving code words used by illicit sellers. Beyond individual messages, it builds a relation graph linking users, groups, and shared media. Graph algorithms detect clusters of repeat offenders and reveal the structure of hidden marketplaces. Every flagged alert is explainable, highlighting key phrases or image regions, and analyst decisions are captured to retrain model periodically, creating a self-improving loop. Using Docker and Kubernetes, it runs as a set of scalable microservices. Kafka handles high-throughput data streams with Redis and Celery orchestrate asynchronous tasks, making the system robust enough for real-time national-scale monitoring. Although this multi-layered technical design transforms it into a living intelligence ecosystem, one that unifies AI, analytics, and human expertise. Altogether, this multi-layered technical design transforms it into a living intelligence ecosystem, one that unifies AI, graph analytics, and human expertise into a cohesive cybercrime detection pipeline.
And lastly, if we talk about the impact and benefits of this, Then the potential impact on targeted audience comes wherein we have a faster detection of drug related chatter and wherein we are using the multimedia evidence. We have the policymakers and regulators wherein the data driven insights to design the targeted interventions and cybercrime policies are stored. We have the benefits as the social benefits majorly being where we are saving the students, the major youth of the country or the world. The economic benefits wherein we are reducing the enforcement cost by monitoring and saving the time and life of people. Lastly, the technological and environmental benefits wherein it is reducing the demand and illegal supply chains of drugs. Thank you.